Our world, Earth, is changing before our eyes. Go back millions of years. Forests reached into polar regions. Sea levels rose, and temperatures soared with high levels of the greenhouse gas carbon dioxide. A long cooling period followed, but now CO2 is on the rise again. What will happen? How will we live in the new world that's now emerging? Scientists are intensively tracking the workings of planet Earth with satellites that chart its winds, ocean currents, temperatures, plant growth, and more. And with a new virtual Earth, shrunk down and converted into physical equations, satellite data, and computer codes, this other Earth, a mirror of the one in which we live, is designed to follow the flow of heat through the complex dynamic engine known as the climate, and to predict its future evolution. You can see the pattern of heat input in this sequence showing surface temperatures. As the seasons shift, heat builds and dissipates, most notably across tropical and subtropical regions. How does Earth dissipate this buildup of heat? Look below. The oceans cover 71% of the planet's surface at an average depth of more than 4 kilometers. They act like an immense battery that can store and release energy over long periods of time, while transporting heat from warm to cool regions. The oceans are set in motion by the unevenness of solar heating, due to the amount of sunlight striking the tropics versus the poles, along with the cycles of day and night and the seasons. That causes warm tropical winds to blow toward the poles and cold polar air to push toward the equator. Wind currents, in turn, drive surface ocean currents. This computer simulation shows the Gulf Stream winding its way north along the coast of North America. This great ocean river carries enough heat energy to power the industrial world 100 times over. It breaks down in massive whirlpools that spread warm tropical waters over northern seas. When heat builds within tropical oceans in late summer, it can be released in a fury. Here is a simulation of surface winds beginning on September 1st, 2012. In that year, the Atlantic Ocean spawned 19 named storms. These and other smaller storms churned up a steady stream of moisture that traveled north aboard immense gyres of wind that circle the oceans. Hurricane Sandy took shape over the Bahamas on October 22nd. Moving north over the open sea, it intensified within unusually warm Gulf Stream waters. Up along the New Jersey coastline, Sandy was slowed by a dome of high pressure to the north. That caused it to turn sharply west into an advancing cold front. The combination brought damaging winds, heavy rain, death, and a trail of destruction estimated at $68 billion. Recent studies predict that as the oceans continue to get warmer, they will release their heat in ever more powerful and more frequent storms. As this virtual planet shows, Earth's climate engine has a dazzling array of moving parts. Wind patterns and sea currents, tides and terrain that together help equalize temperatures around the globe. There's something else at work on our planet. When sunlight bounces off the Earth, water vapor and cloud droplets absorb some of the energy in the infrared portion of the spectrum, transferring it to the rest of the atmosphere. A recent NASA study predicted that if water vapor were the only greenhouse gas, temperatures would fall, sending Earth into an icebound state. Something is needed to act as a thermostat, a control knob to keep the climate steady. Though it's only 0.038% of the atmosphere, carbon dioxide absorbs enough energy to prop up global temperatures and allow water to remain in the atmosphere. It's the settings on this thermostat that are now changing. Since the Industrial Revolution, the amount of CO2 in the atmosphere has increased nearly 40%. Thanks to our vantage point in space and our virtual tools, we have a wide-angle view of the new world that's emerging. However, causes and effects are often jumbled in complex ways. This sequence features a simulation of aerosols in the atmosphere. Fine particles from volcanoes, fires, dust storms, cars, factories, and more. These particles can have an impact on health, as well as the overall climate. Some particles, like sea salt, reflect sunlight back into space. Others, like soot, absorb heat and warm the atmosphere, even as they shade the Earth from solar rays. Add in fires on the surface, detected by satellites and shown here as red dots. They are major producers of carbon soot. They are also a catalyst for change in a warming world. Increased CO2 and warmer weather will bring more rain and vegetation to some places. In others, they'll turn forests into tinderboxes. Flash forward a century. How will Earth look to us then? Will we, its supposed masters, find ways to manage it? Or will we let it slip from our grasp?